Hi everyone, my name is Gideon Besainout and I am an application engineer for Micrographics. Today we're going to have a look at the assembly environment within Fusion and how we can use joints to create our assembly. You'll notice I've got quite a few different parts already created, and we're going to have a look at utilizing the different joints within the environment to create our assembly. Now the first part would be my base plate, and to incorporate this into my assembly, you can simply right click on it, and choose to insert it into the current design. Once it is in the current design, you do have the option to move it up and do any rotations as needed. I'm just going to say OK, as this is going to be my base. You'll notice a small anchor symbol next to the component, and that just means that it is fully grounded and it will not be able to move along any axes. Now I'm going to start incorporating the different parts into my assembly environment. I'm going to go to my part 6, the block, and insert it into the current design. From here, I'm just going to move it up and start rotating it so that I just have a better view of that existing part. Now that this has been incorporated, you'll notice that this is still movable in all the different directions. When we look at our joints, that is what we're going to use to create our assembly. On the motion tab, you'll notice that there's quite a few different options to choose from. Now, when we think about a rigid, that actually locks your component into place and removes all the degrees of freedom. The revolute rotates a component around the joint origin, and you'll still have a revolute degree of freedom. The slider will allow for the component or the part to move along a different axis. The cylindrical still have rotational and slide degrees of freedom. Then you've got your pin slot, your planer, and your ball. Now in this instance, I'm going to choose rigid. I'm going to go to my position tab. I'm just moving this in a different orientation. I'm going to select the center point of that hole and then the center point of the top hole just to get it into place. When we go to our motion, you'll notice there's a preview that shows you that it's locked into place and that it will not be able to move. I'm going to simply select OK, and you'll notice that it has been assembled and that part does not have any degrees of freedom left. From here, I'm going to insert my top plate into the current design. Once again, it will insert it into the origin position. I'm going to move it around and just start rotating as needed, just to get a better view and understanding. You can also go into your X, Y, and Z angles to go and create your different rotational values as needed. Once again, I'm going to choose the rigid option just to ensure that this block is in place and not able to move. I'm going to select the center of this hole, going to my top block and select that point over there. I'm going to say OK. And now that has been placed into position. Going to go and select my coupling. Right click and insert it into the current design. Again, just move it out of the origin position and just give it a rotation just to get a better view. Going to go to joint. Still want this to be a rigid motion. Going to select that top part and that hole over there. Select OK, so that this also does not have any movement. Now this is a boring more guide, a jaw guide and a jaw block, and this is where your jaw will insert and be able to drill a hole into the part that slides in here. Going to go and select the sliding block, insert it into my current design. Going to move this just in the opposite direction and just give it a rotation. Now, when it comes to this item over here, this is something that I would actually like to have a sliding movement so that it's able to move and slide inwards and outwards. I'm going to go to joint, select a slider option, and now I can move and rotate and select the specific point that I want it to slide on. I'm going to just select that edge over there, just going to rotate it a little bit again, and as you can see I'm selecting that point there just to be able to create that sliding motion. Now you can choose your offset values as needed or required, and you can slide it in as needed. When I go to the preview, you'll be able to see the direction that it slides. If it slides in the wrong direction, you can go to your slide and change your axes as needed or required. I'm just going to go and say OK. Now this still has degrees of freedom. You can set your limits and your values. When we open the slider, you can go to the motion and choose your minimum and maximum sliding distance for this to be able to slide inwards and backwards. Now once that is in place, I'm going to go and insert my front plates. Again, it will go to the origin position. I'm just moving it and getting the orientation into a better position by rotating it. Going to go and choose the joint. Going to ensure that this is on rigid again. Going to select the position, that hole in the front, and select that hole just to get it into place. Now there's no degrees of freedom left. You'll notice because this is sliding still, it doesn't have any minimum and maximum values, and that is something that you can set up and create. Going to go to the screw handle. I'm going to insert it into my current design. Once again, it's going to go to the origin position. I'm just going to move it up and give it a nice rotation just to get the better view. When we go to the joint, in this instance, I want this to be able to move in a revolute position. Going to select that top part over on there and that hole. And now when we go to our motion and we go to preview, you'll notice the revolute position that is available and the axis it's actually moving in. Going to say OK. And now when I drag it, you'll notice that when I move it, it actually moves both of those parts together. Going to go and create my top washer, for instance. Going to insert that into my current design. Just move that in a different direction. Just rotate it. Again, moving it to a rigid position so that the washer does not move. Go to my position, select my first point and my second point to get that orientation correct. Now from the Content Center library, you can insert your bolt as needed or required. Now in this instance, I'm just going to go and insert my different pins that has been created. After the pin has been inserted, I'm just moving it and rotating it just for better visual representation. Going to go and choose a rigid group. You can also choose a revolute if you still want this pin to be able to move. Select my position of the hole, and as you can see, that's quite a nice perfect fit. Going to say OK. Now you can go and insert the second pin as required. You can go and insert your bolt, and then you can also go and create your offset values as needed or required. Now to set the limits, for instance, we can simply right click on that joint and say edit joint. We can go to the motion, choose the minimum, maximum and rest values. For instance, if we want the maximum distance to move -70, that should be more than sufficient because there's going to be a part in between, and the rest value we want to be at 0. We can go and preview the limits and we'll be able to see the limitations of that slider. If we're happy, we can press OK, and that would be the limitations that has been set for the sliding block to move, for the part to go inside and for this to move in that orientation. You can also go and create your values for your revolute over here. So this is just the basics of how we can utilize the joints in our assembly environment. Thank you guys for watching. Please like and subscribe for more content.